For section 510, factoring by grouping, I'm going to do some of the problems from the assignment, which was pages 225 to 226. You're doing 3 through 60, not 20, multiples of 3. So you have 20 problems. I'm going to do 9 total, just to kind of walk you through the different types of factoring that you'll encounter since you're doing these over break. Starting with number 3, we'll do the first one. What your goal is trying to find something in common in your two groups here. So right here you're going to separate out your f minus g that's in common between this term and the second term here. So if f minus g have both been used in the check marks, your second set of parentheses is going to be what's left over. And that's going to be the e that's in front of the first f minus g and a minus 4 from in front of the second group right here. And that's all there is to it. You stop right there. Number 6. Now this one's important because when you look at these two, when you compare those two, you have m minus n in front, and the n minus m is called its opposite. Now to understand how that works, if you take that n minus m, and if you multiply that by a negative 1, what you're going to get is a negative n plus m. Now, addition is commutative, meaning that I can switch these and it won't change the sum, meaning it becomes m minus n, which is what we're looking for to get a common factor here and here. What you're going to do is you're going to take this negative 1, you're going to multiply it with the positive p that's in front of this binomial. So when I rewrite it after doing that, nothing changes on the first one, and it'll be minus p. That's the negative 1 times the p. And after that, I can rewrite n minus m as m minus n. And now I have the same setup as I did in number 3. So in common, I have m minus n. And then as what's left, I've got the 7 that's right here, minus p that's right here. And that's your answer for that format. Then in number 12, the only way that that's different is you have 3 separate terms. So you've got the a minus b's in common. So when you pull those out, that will be your first binomial as a factor. And then in your second set of parentheses, you're going to have what remains. So you have the a in front of this one. You have the plus 4b here. And then you have a minus a here. Now you can simplify these parentheses just like you would any others. You have a minus a, so those cancel. So when you rewrite that, it's going to be 4b times a minus b. And I flip those around because since I just have a monomial here as 4b, customarily you write that first. So there's the first 3. Let's move on to problems 15, 21, and 36. Now on problem number 15, what you've got set up is 2 trinomials. And what we need to do with that one is actually factor out anything that's in common. So you see we have an s in each term in this set of parentheses. So let's factor out an s just out of this first trinomial. And that leaves me with s minus 2p plus 2. And in the second set, looks like we have 2 in common. So minus, we'll pull that 2 out, and we're left with the exact same thing as in our first set of parentheses, s minus 2p plus 2. So you have a trinomial in common on this one. So start out with that. S minus 2p plus 2, and that accounts for the 2 that I underlined. And then your second set of parentheses will be the s minus 2 that we have left over. And you can write that with the s minus 2 in front or behind of your trinomial. And there's your answer for 15. Now 21, you don't have any parentheses there, but it's the same basic format. If I pull out an a in the first set, what I'm left with is 3 plus b. And what I'm hoping for is that when I pull out common factors of the second set, which I have a c in common on both of those, that I'll have the exact same thing in my parentheses, which I do. I'll have a 3 plus b. Now to go on to answer that, you're going to have the 3 plus b that's in common right here and right here. And then in your second set of parentheses, you've got a plus c. That's what's left over. And there's your answer there. And for number 36, it's the same thing. We already have it split out into parentheses on this one. And you have an a squared right here and here. Now just to see if that's the direction I want to go, I'm going to look at this second set of parentheses and see if I pull out a common factor, if I'll get the same thing. So if I pull out an a squared, I have a b squared plus 2. Right here I can pull out 2, and I can pull out my a. So that would be b squared plus 2. So let's go ahead and write that out. On the first set, I've got a squared with b squared plus 2 in parentheses. And then minus, let's pull out 2a, leaving me with another b squared plus 2 in those parentheses. So in my next step, the b squared plus 2, which can't be factored, that can't be factored further. You want to be watching out for that as the problems get harder. You've got that as your first set of parentheses, and then you have a squared minus 2a in the second set. Now you notice in that second parenthesis, I have a in common, so you want to go ahead and factor out that a. You're trying to break this down as far as it can go. And that's going to be a times a minus 2. So I'm going to put that in front. I turn that around since I was pulling out a monomial. And then don't forget to put your b squared plus 4 back in there. So you have 3 parts of that answer as it gets a little bit longer. And so there's your first 6, and moving on to the last 3 I'm going to do, 39, 45, and 60. And the way 39 is set up, you have a perfect square here, and you have a square here. Instead of factoring all of this out, that's not the direction you want to go. This negative between my 2 perfect squares is just like having a difference of 2 squares. So what I'm going to start off with is just 2 sets of parentheses. And let me get my highlighter. The x squared is going to be this number times this number. My y minus z squared is going to be here and here. And I'm going to separate those using the difference of 2 square patterns of plus minus. So to get x squared, it's x and x. And then insert my y minus z's. I'm just going to nest those parentheses inside and do another y minus z. Now the reason those parentheses are important is because this negative sign will now affect both terms that come after it. So your final answer, your first one, there's nothing to distribute, so we'll just rewrite without the parentheses. And then the second one is going to be x minus y plus z. And that's the effect of that negative before the set of parentheses right here. Right, number 45. You've got, on this one, also be on the lookout for any time that you can split into a trinomial square, difference of 2 squares pattern. This negative with b squared at the end is going to be similar to 39 backwards. A squared plus 4a plus 4 can be rewritten as a plus 2 squared minus b squared. So it's the same thing that we had in 39. I'm going to show, let's go ahead and put the parentheses in again. And let's show that with the highlighter. The b squared is going to be b times b over here. And I'll put those in a minute. And then the a plus 2 squared is going to be here and here. And those will be separated by the difference of 2 square pattern difference of two squares, plus minus. So let's put our b's in, and then in front of that we're going to have a plus 2. Now since there's not going to be any negatives to distribute, I don't need to worry about the parentheses on this one. So that's going to be my final answer already. So you can see it by working that out up here, you would have made that a lot harder problem doing y minus z minus y minus z. That would have given you y squared minus 2yz plus z squared, and you wouldn't know where to go with it besides refactoring it to this. So once you get that pattern to see how that works, you're going to take this into a perfect square, and your problems will be set up that way, so it'll come out that way on purpose. All right, and finally, let's look at number 60. This is your last one of the problem set. And on here, we did this one in class. Let's just a quick refresher on it. You've got a binomial in front that you can factor out as a difference of two squares. And that would be h plus 2k and h minus 2k. And then what you're hoping for the rest of this is that you can find something that's going to be in common that creates one of these two terms, either the h plus 2k or h minus 2k. So if you factor out the 4, you get h minus 2k. Now that works out perfect with what we want to do. We have an h minus 2k in common in both. So we're going to do the same thing that you did earlier on in the problem set. I'm going to put that h minus 2k as my in common binomial. And then what I have left will go into trinomial fashion. So put h plus 2k and then just insert that plus 4 right after that. And that's where you quit. And so that was pretty quick. You might want to go back and just take a second look at how some of those work. You've got 11 more to do independently, so try to have that ready when we start class on Monday. We're just going to quickly run through it, and we'll be starting 511 using several methods of factoring. So have a happy Thanksgiving. Good luck.